find the limit of x sine of x as x approaches 0 using the sandwich theorem, or it's also known as the pinch theorem or the squeeze theorem. This theorem states that if g of x is less than or equal to f of x, which is less than or equal to h of x, and if the limit of g of x as x approaches a constant equals the limit as x approaches some constant of h of x equals the same limit, then the limit of f of x as it approaches the same constant is the same limit. And this works because if the limit of these two is the same and this is between these two functions, then it must be the same. For this equation here, we have to decide what our limits are, what sine of x is always less than, what is always greater than, less than, or equal to the sine of x. The sine of x is bounded by 1 and negative 1. It's always equal to, less than, equal to, less than, or greater than these numbers here. But to make it look like x sine of x, we have to multiply each portion by x. So negative x is less than or equal to x sine of x, which is less than or equal to x. Now, if we graph this, negative x looks like that. Positive x looks like this. And they, at x equals, as the limit as x approaches 0 is 0. So, stated by the sandwich or squeeze theorem or pinch theorem or whatever you know it by, the limit of x sine of x as x approaches 0 is 0. And this here, if this is pi, negative pi, and this is pi, the graph looks about like that. It also passes through x equals 0. So the limit of x sine of x as x approaches 0 is 0.